Arrays in Python are powerful for data handling, allowing efficient storage and manipulation of data. Key operations include indexing, slicing, and iterating. Understanding these operations is crucial for tasks like data analysis and scientific computing, where performance and memory efficiency are paramount. Python arrays are a fundamental data structure, storing elements of the same type in contiguous memory locations. This allows for efficient data handling and predictable access patterns. Arrays can be created using Python's built-in array module for basic operations or the NumPy library for advanced scientific computing, offering high-performance storage and computation. An array in Python is a collection of elements of the same data type stored in contiguous memory locations, allowing predictable access patterns. Arrays support efficient operations, offering high-performance storage and computation compared to standard Python lists. They can be implemented using Python's built-in array module for basic tasks or the NumPy library for advanced scientific computing. Creating arrays in Python can be done using the array module or NumPy. The array module allows for simple arrays with type codes like I for integers and F for floats. NumPy, however, supports complex operations with one-dimensional and two-dimensional arrays, enabling vectorized operations and extensive mathematical functions, crucial for data science. Creating arrays in Python can be done using the array module or NumPy. The array module is straightforward, as shown with r.array I left bracket 2, 4, 6, 8 right bracket. NumPy, however, provides enhanced capabilities, demonstrated by np.array 1, 2, 3, making it ideal for complex numerical computations and data analysis. Array elements are accessed using zero-based indexing, where a zero retrieves the first element. Negative indexing allows access from the end, with a -1 fetching the last element. Slicing operations, such as a 2:5, extract subarrays, returning elements at indices 2, 3, and 4, as the end index is exclusive. Using NumPy, access elements with indices. Data 0 gives 10, data -1 gives 50. Slicing examples include data 1:4 for 20, 30, 40, data 3 for 10, 20, 30, and data 2 for 30, 40, 50. Note: slicing creates views, not copies. Changes affect the original array unless .copy is used.